Hello, Web Summit. Hi, my name is Aline. I am one of the co-founders of Traive. And I'm here today to introduce you one of our latest research and development in the field of graphical aware LLM. Let me start with financial risk analysts and traders are one of the most complex logical tasks in the world. These human beings, they basically have to perform very complex mathematical analysis, and in domains like agriculture, they often have to do it with a very scattered, fragmented, and incomplete data, which makes their life, which basically they have to do logic and abductive reasoning to derive conclusions, which informs the money flow in the world. And the problem becomes when the capital market foundation is based on trust. Trust is coming from information, from data, factual data. And everyone here in this audience knows this marvel that is large language models. And now AI become tangible to us. The problem relies in the fact that the transformers architecture that empowers those LLMs, they're not the most suitable and the best ones for certain domains like finance, risk analysis, trade, or even healthcare. Because the learning mechanisms of those deep neural networks require a bunch of data, of which most of the agricultural and financial or credit risk, they are not available in the web for those models to have been trained. Not only that, they don't have necessarily, when they learn something, they don't have the context, hierarchies. They are just a repeated process from the patterns of the tokens that they had. So how do you do it? Let me explain about this, abductive reasoning. Abductive reasoning is this very magical skill that only human beings, so far, can do it. And abductive reasoning is this ability for us human beings to learn from very limited and small data, but it still elaborate on plausible, cohesive, contextual inferences about an event. And here's an example, right? When you go to the LLM and you ask and prompt, hey, what is a pen, paper, and finger? A human being would straight derive to say, it's a pen. And you can still see from this researcher in AI field that they prove. The LLM, you say, what is pipe, finger, ball pen, and press? We're going to say calligraphy. And every iteration that you do, you say something different and wrong, right? And you cannot have something different and wrong when you're talking about dealing with people's life or money. So there is a better way to do it. And this better way, we have been in the field of research and development of graphical neural networks for quite some time. And we found out in our latest research that actually merging this with the LLMs, where you introduce a graph knowledge-aware model to the LLM, they reason better, and they don't hallucinate, and they can achieve the task that you, in that particular domain, you want these classifiers to do it. So I know this is technical language, so I brought Sebastian to help me to make this audience understand what is this. This little creature, fluffy creature is my dog. So if you go to ChatGPT and you prompt and ask, hey, ChatGPT, write me a sentence that describes Sebastian, which is a golden retriever. And you notice that the learning mechanism, how it works, Sebastian is associated with he, because there is a bunch of labeled data in the web that associates Sebastian as a male name. Therefore, he's a he. And golden retrievers, I mean, how many people you don't post in the Instagram and say this is a cute, good-looking, and good boy, right? Therefore, induces, okay, good behavior. But notice that the learning mechanism didn't learn anything, and it still deceived me and say, wow, it understands about Sebastian. But how can you factually know that Sebastian is a good boy? So instead, what you have here, how the graph would work, you have here Sebastian as a node, right? So you train these models in a way, and with the data and the context and the domain knowledge of that, like owners of golden retrievers, like me. And then Sebastian, therefore, is a golden retriever, and you get a bunch of, is associated with a bunch of scientific publication that describe that golden retrievers, 70% of the golden retrievers are good boys, 30% of the golden retrievers are bad boys, because you still have the bad cases. You also can introduce to this graph a notion of who are their parents, which is something in the LLM, they don't have the context of parents and child. They don't understand it. They are not wired that way. So the graph does the job, and therefore, you introduce that's Aline and Fabricio, and this model, based on every public data that can be available to it, can understand and it take information, and they see, okay, Aline 84, Fabricio born in 82, and there is no human registered under the names as a child of these two human beings. Therefore, those are millennials, and hence they are dinks, dual income, kidless, no kids, millennials, which shower this dog with love and money, which actually probabilistic means this, he's in the 99% trait that he's in the good behavior. So you see how it's more complete and factual driven. And let me show you another cool thing about these models. Part of the LLMs is the adaptive learning for how the human brain, I can learn new things just by watching you right now, right? Without having to have a bunch of historical experience on being this stage. So let's say that there is a new word introduced here, which is safadinho. Safadinho is how I call Sebastian, because safadinho is, for those who are not Portuguese native speaker, means naughty in Portuguese. And what does it mean? Because safadinho here, or naughty, can have completely different contexts or interpretations or meaning, depending on the context, right? Safadinho for a male or a woman, it can be something different, or in a funk music, right? So in this context, therefore, you introduce to this graph the term safadinho, and you allow it to be iterated with the priors of golden retrievers owners, which it tells through their experience that one safadinho means that, okay, one every 20 commands, this dog doesn't behave like he was supposed or expected, right? That's how you can, therefore, make these machines iterate better with the human knowledge and both achieve what either could achieve alone. So what I just showed to you, it's published. We have been presenting this work and selected to present in the major AI conference peer-reviewed, so you can definitely check it out. And what we prove in our research and mathematics is that this type of architecture of AI provides better predictions, strong adaptability, and user experience. And today, we are doing a launch. So I'm very proud. My team has been working so hard on that. Here's Traive's chat in action. 2 hours ago, it was in production. An analyst for the agricultural supply chain doesn't have enough data about their farmer, so they just put the ID, and then Traive's chat starts to do all the abductive reasoning, hit a bunch of APIs about the data that models the farm, the weather, the system, the financial markets, in order to derive very logical and plausible conclusions about the potential cash flow components of that given farmer, and hence also deduce or infer the probability of delay and default with a very small data without hallucination. This saves 1 million hours of cost. It turns the financial risk analysis or trading and merchandising way better and faster. And these models, what statistically they show, they outperform by 5 to 6 times any classifier in the financial or any classic neural networks, because it's all about how the human is wired, the brain is wired to small data. So if you became interested about our research and development, please reach out. I'm leaving here my email. And thank you all for your attention for today.